Question 6.8. 17 people have been exposed to a particular disease. Each one independently has a 40% chance of contracting the disease. A hospital has the capacity to handle 10 cases of the disease. What is the probability that the hospital's capacity will be exceeded? Okay. All right, so let's define some variables. So X is going to represent the number of people who contract the disease. Now, a couple things we know. 17 people are exposed, so we can think of that as the number of trials. Okay. Each person independently has a 40% chance of contracting the disease. So the probability of success, and I know it sounds kind of grim to talk about success as contracting a disease, but in this context, that's what it is. Okay. The probability of success is 40%. Okay. All right. So this is already looking a lot like a binomial random variable. Right? The outcomes are binary. Success, get the disease. Failure, you don't get the disease. Trials are independent. It says right there on the second line. We're looking at the number of successes. Or sorry, the number of trials is fixed, right? N is 17, right? No more, no less. And then we have the same probability, 40% on every trial. All right, so this is a binomial. So X has a binomial distribution with N equals 17 trials and P 40% chance of success. Okay. So we want to find the probability that the hospital's capacity is exceeded. So in other words, that we exceed 10. So that means 11 or more. What's the probability that X is greater than or equal to 11? Okay, so there's a couple ways we can calculate this, right? We could find the probability that X is 11 and the probability that X is 12 and 13 and 14 and so on all the way up until 17. We can calculate each one of those probabilities individually and then add them up, but that would be a lot of work. That'd be a lot of plugging in to the binomial formula. But there is a faster way if we're clever about it. So let's make a distribution. Okay, so X, the number of people who contracted the disease, and the probability of X. Okay. Now, best case scenario, nobody gets the disease, right? Everybody was exposed, but nobody actually gets the disease. Okay, maybe one person gets it, maybe two, maybe three, right? Maybe 9, maybe 10, maybe 11, right? Maybe 16. But the worst case scenario is that every one of those people contracts the disease. Okay. All right, we are interested in the probability that 11 or more people get the disease. So we're interested in this part of the table. Okay. Now, as I was saying earlier, we could calculate every one of these probabilities individually and add them up. Okay. But that's a lot of work. So instead, what we'll do is we'll find the probability of everything else, right? Of the outcomes 0 through 10. Okay. Now that seems like silly. Why would we do that? Well, we're using this fact that the probabilities have to add to 1. I forgot the word 2. Add to 1. Okay. And there happens to be a very convenient function on our calculator for finding the probabilities of a bunch of outcomes up to a certain point, right? And this is the binom CDF function. All right, now I don't really have a way of projecting my calculator here on the screen recording, so I'm just going to describe what I'm doing on the calculator. So pressing second vars, and that gets me to the distribution menu. And then I'm going to scroll down past like the normal functions, and get towards the end of the list, and there's binom PDF and binom CDF. CDF is the one that we're looking for. Okay, so it's asking for the number of trials, which I know is 17. It's asking for P, the probability of success, which we know is 0.4. It's asking for the X value, so that is the maximum value we want to go to, in this case up to 10. And that's it. It just needs those three inputs, okay? Trials, probability, and the boundary value, in this case 10. Okay, I'm going to press, well, I need to type in those values first. And then press enter, and it tells me the probability is 0.9652. I rounded that. Okay. So that is the probability of having 10 or fewer people contract the disease. Okay. That's not what we wanted. We wanted the probability of 11 or more people contracting the disease. Okay. But the sum of those probabilities combined with the sum of these probabilities has to equal 1. Well, I know this. We can subtract from 1, and then we'll get the remainder, which is going to be that. Okay. All right, so 1 minus 0.9652 is equal to 0.0348. Okay, so that is the probability we're looking for, and that, if we round, matches choice B. Now, I really want you to be convinced that this works, so should have probably tested this out first, but let's try something. Let's go to good old Staplet.com, and there is a binomial distribution section here, right? So we just have to type in 17 and 0.4, plot the distribution, okay, and then we could calculate the probability of at least 11 successes, right? And that would be 11 or more people contracting the disease. And it says here the probability is 3.48%, which matches the math that we did here using binom CDF on our calculator.